This video is going to work through a couple of dozen review questions that will help you prepare for the AP exam, as well as help you prepare and remind you of some things that we haven't done since the beginning of the year in preparations for next week's in-class open notes, open textbook quizzes that will also be reviewing you for your AP exam. All right, this question, DA11, given the cumulative plot, what ages would be considered outliers? This is a classic example of the type of question. Often at the beginning of the year, we did not calculate outliers by ourselves. We just put data into our calculators and had it tell us, maybe through a modified box plot, whether or not there were any outliers. But here you can't do that because there's not data to put in. So you really have to understand the formulas and how to work with the formulas for calculating data values that are outliers. All right, so the first thing you have to do is calculate the interquartile range. That's Q3 minus Q1. We multiplied that result by 1.5, so that's 1.5 IQR. And then that's like our measuring stick. If any data values are 15 values below Q1 or more than 15 above Q3, we would call those outliers. Technically, the number 25 and 65 would not be considered outliers. It would have to be more than 15 away. So technically speaking, 15 below and 15 above would not be outliers, but anything beyond that. Our DA12, data on ages in years and price in $100 for 10 cars of a specific model result in the regression line predicted price equals 250 minus 30 times age. Given that 64% of the variation in price is explainable by variation in age, what is the value of the correlation coefficient R? The key here is that this 64% of the variation in price is explainable by variation in age is a very specific term and that refers to, and that's sort of the hint there. All right, so we first know that that refers to the R squared, or the coefficient of determination. We take the square root of that, and that gives us our R. So we know the magnitude of our R is 80%, 0.8, but the slope of the regression line is negative, and the sign, SIGN, of the slope and the sign of our correlation coefficient always are in agreement. So we know that our R must be negative 80% or negative 0.8. All right, given the DA13, given the two histograms, which of the following statements is incorrect? All right, so you might look at those histograms and say, well, we don't really know what the mean is and the median is because we don't really know what the values are specifically in each of the bars of our histogram. But in this case, we do. This is not your typical histogram. These histograms are centered on particular values. So the values in this bar are all 10. The values in this bar are all 20 because they're centered on a particular value. So we can say for sure that the mean is 45, the median is also 45. We know exactly what the range is in both of them, 80 minus 10, which is 70. And then set A will have a bigger variation because it has larger numbers of values on the outside at the extreme values. So its variance will be larger, even though the ranges are the same. The maximum minus the min are the same. Those are both different measures of spread, but the variance is definitely larger in set A. And then we don't have any Y scale, so we don't know how many elements are in each set. So that is why E is false. All right, DA 22. If every woman marries a man who was exactly 3 years younger than her, what would be the correlation between the ages of married men and women? So in this case, you could almost picture a graph. And so if a woman is 20, then she's going to marry someone who is 17, right? And so it's going to, those data values will be an exact line. And so as a result, the R value will be 1. All right, DA 18. Given these parallel box plots, which of the following statements is incorrect? All right, so all the other statements are true. The ranges are the same. The IQRs are the same. Remember, the IQR is the width of the boxes in the box plot. C is wrong because it doesn't make any sense. That term skewed to the left and also skewed to the right, or skewed low and skewed high, doesn't make any sense. You can't be skewed in both directions. A may or may not be symmetrical. It looks fairly symmetrical, but you don't know what the actual data values are, so good chance it wouldn't be exactly symmetrical. And then yeah, we don't know how many data values are in each set. All right, P8. An insurance company charges $900 annually for auto policies for teenagers. The policy specifies the company will pay $1,500 for a minor accident and $8,000 for a major accident. If the probability a teen will have a minor accident is 15% and the major accident is 5%, how much can the insurance company expect to make on 10 policies? So this is expected values, and how do we calculate expected values? All right, so in this case, the expected payout would be, we would multiply each of the amounts of payouts by the probabilities of each of those occurring, and that would give us $625. So they would expect, on average, to pay out $625 per policy. So they charge $900. So the profit per policy was 900 minus 625. And then there we're talking about 10 policies. So we simply multiply that by 10. All right, DA 19. Suppose the average score on a national exam is 500 with a standard deviation of 100. If each score is increased by 20 and the result is increased by 10%, what is the new mean and standard deviation? So this is how we dealt with random variables and how the mean and standard deviation increases. What things affect mean? What kinds of things affect standard deviation? Okay, so if you remember, the mean is affected by both adding the 20, but also is affected by multiplying by 10%. And so that's why it changes from 500 all the way up to 572. The standard deviation, however, remember, that is not affected by increasing of 20, so we simply multiply by the 1.1 or 110%. DA 16. Which statement is true about the correlation of the 3 scatter plots? So think about looking at those scatter plots. Some of them are pretty easy to calculate, or you could guess at what the R values would be. Correlation, remember, is the R value. So go ahead. All right, the last two are, if we were to do a best fit line, I think that best fit line would be horizontal. So the R value would be 0. There really is no linear relationship there. And the first one is definitely negative, and it's pretty close to 1. You might argue that it's curved, and so maybe linear data wouldn't be the linear model wouldn't be appropriate, but you would still get an R value close to -1, even if maybe it's not linear and a linear model is not appropriate. DA20, which of the following statements about residuals is incorrect? All right, so E is the only one that is incorrect here. They reversed it. The residual is Y minus Y hat, not Y hat minus Y, right? The predicted Y hat minus the observed Y, that's wrong. It should be Y minus Y hat. DA21. Consider the picture of revenue over 3 years. Which of the following is true? All right, so none of the other statements are true. This is sort of a misleading. Remember, this is not really a histogram. This is a misleading graphic because we did not start the y-axis at 0. So it looks like there's a huge difference. Looks like we dropped by half from 2015 to 2016, but we really didn't. We dropped from 200,000 to 195,000. So we only dropped 5,000 in value. So this is a misleading graph. It is not a histogram. ED5. Food critic is given an assignment to choose and sample food from 52 New York City restaurants. She lists all restaurants whose names start with A, assigns each a number, and randomly chooses 2 numbers and thus 2 restaurants. She repeats this process for every letter in the alphabet and creates her list of 52 restaurants to visit and review. Which is a true statement? All right, she definitely is using some chance procedure, but she's not doing an SRS. Not every restaurant is equally likely of being selected. So for D, for example, that restaurant begins with M, probably more restaurants beginning with M than beginning with X. And so M actually has the restaurants beginning with M. There's more of them, and she's only choosing 2, so they're less likely to be chosen. There's not as many restaurants that start with X. So since there's fewer X restaurants, and she's picking 2 from that group too, those have more of a chance of being selected. And then systematic is a type of sampling that we don't really even talk about, but it does not apply here. P7. A television game show has 3 payoffs with the following probabilities. So you can either win 0 money, and that happens 70% of the time. You can win $500, that happens 25% of the time. Or you can win $5,000, but that only happens 5% of the time. All right, what are the mean and the standard deviation of the payoffs? You could do this by hand because the number of payoffs is so few, 3, so you could probably do it by hand, but you can also use your calculator to do this using your lists. All right, so in general, the expected value is going to be the payout times its probability, so 375. If you weren't able to calculate the standard deviation, at least you could probably narrow down your choices. But you could do this in your calculator. All right, so we put the payoffs in list 1 and the probabilities in list 2. We do a calculation. We go to stat calc, and then we do a 1 var stats, and then list 1 is the list, and list 2 is the frequency list. So probability or frequency, and then hit calculate, and it gives us our X bar, which is our mean, and sigma, which is our standard deviation. ED12, sampling error occurs. All right, so sampling error always occurs when we're sampling. There's no way around it. So it's not because we did something wrong. The interviewer made mistakes, or somebody used judgment too badly, or the sample was too small. It's going to occur no matter when you sample. So every time you sample using a statistic to estimate a population parameter, you're always going to have sample error. ED 13, which of the following is the most important in minimizing the placebo effect? Okay, so all these things are sort of important. We want randomization, we want control, we want all these things are important. However, in order to minimize the effect of placebo, you want a control group, hopefully using a placebo, and then you also want blinding so that people don't know. So those are the two most important things. These are all important, but the two that are most affect the minimization of placebo effect would be blinding and a control. P1. Review Book A advertises an average SAT gain of 40 points and a standard deviation of 12 points. Review Book B claims an average SAT gain of 35 points with a standard deviation of 15 points. Assume that both assertions are correct, and assuming normal distributions, which book is more likely to result in an SAT gain of 60 points? All right, so C is correct here. They both actually get the same probability. As it turns out, it's kind of weird. They specifically pick the values in such a way here that 60 is the same number of standard deviations above the mean for book A as it is for B. Looking at this with more detail, we can see in book a z-score of 1.667. If we looked at the z-score table, we would see about a 5% chance of this happening. We could also look at normal CDF with a low value of 60, a high with a very large number, I picked 1,000, with the mean of 40 and a standard deviation of 12 gives us a 4%, about 5%. If we look at book B, strangely enough, book B 60 is 1.67 standard deviations above its mean. So at this point, since we see that their z-scores are the same, we know that their probabilities are going to be the same. But you could also have skipped over the z-score and gone right to the both of them using a normal CDF. So again, 60 as your low, 1,000 as your high, a mean of 35 and a standard deviation of 15. So they both give us about a 5% chance. ED9, a sales representative wishes to survey her client base of 47 companies. She has 47 business cards, all of the identical size from her contacts in the companies. She drops all 47 cards into a small box, shakes them up, and reaches in and picks 5 cards. What type of sampling is she using? This is clearly a simple random sample. Each card is equally likely a chance of being selected. ED27. A botanist is running an experiment on 2 fertilizers that require different amounts of watering. She has 20 sunny and 20 shady plots. She randomly selects 10 sunny and 10 shady plots for which to use 1 fertilizer with appropriate watering, while the remaining plot gets the other fertilizer with its appropriate watering. Which is the most important observations about these procedures? So in other words, with the appropriate watering, so she's just looking at on the bag, the fertilizer bag, and it says use this much water. So that's what she's doing. She's using the appropriate amount of water that each fertilizer recommends for its fertilizer. All right, so it's the fertilizer and the water that are confounding because perhaps the the amount of water is better in shaded region versus sunny regions and that kind of thing. So the fertilizer and the water are the confounding variables here. ED 27. Which of the following statements is incorrect? All right, so let's just go through some of these. Convenience sample often lead to undercoverage bias. That's true. Convenience sample is really like you just ask your 20 friends rather than sampling, randomly sampling 20 people. Voluntary response is incorrect because it often overrepresents people with strong opinions. This is like Yelp. If you have a bad experience at a restaurant, you're probably more likely to go onto Yelp and complain about it than if you just had a decent restaurant experience. All right, C, questionnaires with non-neutral wording are likely to have biased response. That's true. There is no way to fix results of a biased sampling method always employed. So that's true. There's no way to fix that. If you did not sample properly, you're done. Non-response bias should be avoided because those who do not respond might have differing views from those who do respond, and that's true. ED 30. A customer product agency tests kilowatts per hour for a sample of 3 refrigerators, each one of 3 different sizes. Which of the following is true? All right, so D is true. There is one explanatory variable, the refrigerator, and then there are 3 levels or 3 different types of that one type of refrigerator. All right, ED 42. A candy manufacturer wants to test the consistency of sugar content of chocolate-covered cherries produced in one factory. The company decides to randomly select 3 boxes of chocolate-covered cherries from each day's production run and analyze every cherry in each of the 3 boxes. What type of sampling is this? All right, this is clustering. P2, suppose the probability that an answer can be found on Google is 95%, on answer.com of 92%, and on both websites of 87.4%. Are the possibilities or probabilities of finding the answer on the 2 websites independent? All right, yes, they are independent. If we multiply the 2 together, it gives us 0.874. This students find rather confusing. Remember that if they're independent, the probability of an event F happening, given that E has already happened, is the same as the probability of F happening. So F doesn't depend on whether E happened or not, and that's what we mean when we talk about independence. So we know that the probability of E happening and F happening, the probability of F and E happening, is equal to the probability of E happening times the probability of F, given that E has happened. However, when they're independent, I can replace the last part of that calculation, probability of F given E, with just probability of F. And since that's true, if you look at the numbers up above and you multiply them together, that works. So this tells us that yes, they are independent. P3, suppose that 80% of jurors come to the just decision. That means, if the person's guilty, they find them guilty, or if the person's innocent, they find them innocent. In a jury of 6 people, what is the probability that more than half come to the just decision? As a hint, this is a perfect binomial situation. Now, normally jurors have 12 jurors on a jury, but to keep this problem simple, they went with 6 persons on a jury. All right, so remember, it's helpful if we write down all the possible outcomes, right? We could have 0 people come to the just conclusion, or 1 or 2 or 3 or 4 or 5 or 6. So if we say, what is the probability that more than half would be 3, so more than half would be 4, 5, or 6 of the jurors come to the just decision. All right, so that's a binomial situation. Remember, so we are going to want to, in our binomial calculation, we have to look at these numbers. So we have to use 3 or below. And so we do, remember the sum of all the possibilities is 1. So we do 1 minus a binomial CDF with 6 is the number of trials. The probability of success for any given trial is 80%. And we want to use 3 because that, if with a CDF, it's going to be 3 and everything below it. And so we'll subtract that from 1 and get about a 90% chance that more than half of the jurors will come to the just decision. P4, the following is from a particular region's mortality table. All right, so your age and the number of people alive when they reach that age. What is the probability that a 20-year-old will survive to 60? Okay, so this is a conditional probability. It's really what's the probability that you live to 60 given that you had already lived to 20. And so our formula would be the probability that you live to 60 and 20, which is really just the same as you live to 60, because if you live to 60, you clearly had already lived to 20, divided by the probability that you lived to 20. And so we get about 80%. P6. Suppose that 53% of adults have trouble sleeping. If a doctor contacts an SRS of 85 adults, what's the probability that over 55% have trouble sleeping? Hint here, check for large count conditions so that you can treat this as a normal distribution, and we will do a normal calculation here rather than a binomial. All right, so we checked the large count, so n times p and n times 1 minus p, both of those are larger than 10. So we can use an approximate normal distribution here. So what does the normal distribution look like? We want to look at our mean of our normal distribution will be p, the true proportion, and we are assuming that that is 53%. And we want to calculate the standard deviation, and that's the square root of p times 1 minus p over n. And then we just want to throw that into our normal CDF, would be the most efficient way of calculating that. The low is our value, our actual value, our p hat in our case. We want to know what's more than 55%, so 0.55. Up to just an arbitrarily large number, I used 100. The mean is 53%, standard deviation of about 5%, and that gives us something like 35 or 36%. P10, which of the following statements is correct? And these are all dealing with the shapes of a binomial distribution. All right, so yes, the histogram with a p-value of 0.5 will be symmetrical, not necessarily normal, but definitely symmetrical. Histogram of a binomial, the histogram of a binomial distribution with 0.9 is unimodal. Yes, they're all going to be unimodal. Histogram of a binomial distribution with p of 0.99 looks more and more symmetrical as n gets larger. That's true for D and E. As n gets larger and larger, we are going to have a distribution that looks more symmetrical and perhaps even more normal if n is large enough. So B is the only one that is incorrect. Of a p-value of 0.9, it's not skewed right, it's actually skewed to the left. P9, a travel agent books passages on 3 different tours. Half of her clients choose tour 1, 1/3 choose tour 2, and the rest choose tour 3. She has noticed that 3/4 of those on tour 1 rate the trip excellent on Yelp, while only 2/3 of those on tour 2 do, and only half of those on tour 3 rate it as excellent. If one of her clients rates her trip excellent, what's the probability that he was on trip or tour 2? You can either make a tree or a table. In this case, I think a tree might be more helpful in the way that they gave us the information. All right, so we have the certain percentage of her clients that were on the different tours, tour 1, tour 2, and tour 3. And then we also have the percent of those individual tours that rated it as a check mark or excellent. So we are trying to calculate what's the probability. Remember, when we look at working through these, we want to multiply through the tree diagram, and that gives us the probability that both things happened. Remember, this is a conditional probability, but if we multiply them together, we get the probability that that someone randomly selected was on tour 1 and rated the tour as excellent on Yelp. So what we're trying to calculate is, given that they gave an excellent rating on Yelp, what's the probability that they were on tour 2? So what's the probability they're on tour 2 given that they said excellent on Yelp? So we again can use that calculation, the probability of tour 2 and excellent divided by the probability of excellent. So the probability of excellent would be the sum of these 3 probabilities that we have here. All of these are people that rated them excellent. So the sum of all that gives us our 49 over 72. And then the probability of tour 2 is simply this working through this branch through our tree diagram.